Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. Today we've got Peter who has just completed the course Linux Basics for Robotics, and he'll be giving us a presentation on that. So without any further ado, let me hand over the platform to him so that he can begin his presentation. Alright, I think you asked me a question, so it does not reset your connection, no worries.
Okay, yeah. I don't know. I think I did something on my end to close it out or something.
Yeah, okay, so
Um,
you can go ahead now.
okay, cool. So I'm just gonna run my uh avoider program, I guess, to start, and then I'm gonna run my statistics program. I can get it. Okay, I'm just waiting for the nice. Okay, so what seems to be working. All right. So the statistics is just getting in uh, basic position and linear velocity, and when it starts to turn, it'll get the angular velocity. Um,
Mm-hmm.
as far as the top window, that's just showing what the scans are getting and the parameters that it's setting before it starts to scan is like setting the linear velocity to 0 and the angular velocity to 0, so that it's not constantly moving. Um, and then like hitting a wall or something. Uh, do you want me to go over the code?
Yes,
Um,
please.
okay.
So right now you've just been showing like basic obstacle avoidance is required by the project, right? So, but we want to know in more detail, how did you manage to achieve that behavior, and how did you develop your statistics script?
Yeah, okay. So the main things that you want for the obstacle avoiding thing is you don't want to take anything. So you set a minimum threshold for like the distance, like the minimum or maximum distance away from an object that you can have. And so my current maximum distance is like 0.3 meters away. So you'll see that it stops like around 0.3 meters away from any objects.
Mm-hmm.
And then you also incorporate which you have to get the areas for the robot that are like open to move, essentially. And so what we mainly did for this project was taking in whether or not the front right, front left, or the front is clear, and did a whole bunch of if statements of um, like I'm gonna go over later. If my if block of if the front left is clear, if the front is clear, but the front right is not clear, and after you've met those thresholds, then or after you have those parameters, then you execute this like some code, and then you set the parameters back to 0, and that's angular velocity and linear velocity back to
Mm-hmm.
0, and then you just repeat the process. Um,
Can you be showing
right now, it looks like it's
where
working.
in the code editor this happens? Because at the moment, you are trying to explain it in abstract terms, right? So I think it will be easier for you to,
Yeah,
yeah, show where this is happening and how you manage to get that behavior?
Do you want me to open?
Mm-hmm.
'Cause I have a Google Doc with some like an if block that has like most of the stuff that I want to go over. If you want me to open that one up.
So right now I want to see in the code editor, right? You can go back to your slides back and forth, but the code editor is the
Okay.
best way to start.
Okay. Cool.
You could use the
Okay.
one next to the terminal to open in standard IDE. Unless you prefer Vim, then you can just maximize that and then we can talk about it there.
I think I'm just gonna do this because I think I'm more familiar with
Okay, that's cool.
doing.
That's good.
Okay. And I'll do it so that y'all still see the robot. All right. So to start off with, what you're seeing, can you see when I highlight?
I can see your
Highlight?
case, but I'm not sure if you'll be able to highlight. Can you try? Yeah, when you highlight, I can see.
I just. Okay. So all the stuff that is highlighted, right? All the stuff that is highlighted right now is getter functions. So basically, it's taking in data from the robot currently. So this is where you'll get the stuff that I was talking about. So you'll have front right, the front scan, and the front left scan, and then I also include right scan and left scan, just in case I needed it. And then you have setter functions, which essentially like publish data to or send data to the or allow you to send data to the robots. And that's how you can set the angular velocity and linear velocity to 0.
Okay.
And so here are the setter functions. And then I just have like just running the bat, showing that the script is running, and how to exit the script. Just basically, it's like a print out. Can you hear that?
Yes, I can hear you. I wanted to
You can.
ask you something about your getter functions, right? So,
Okay.
can you explain what is happening after the pipe operator, right? So, for example, if you look at the one at the top, we have ROS2 param get, and then you specify robot interface, set front left ray, right? So, can you explain a little bit what's happening after the pipe, right? What are you doing there? What does AWK and print $photo?
AW.
Did you at least think about what was going on when you're putting it together?
I think I remember seeing it somewhere. I can't remember off the top of my head. I think that from what I remember, the dollar or the $4 is the specific location that you're printing it to. I could be wrong about that.
Yeah, you're correct. It's a specific location, right?
Okay.
But what is happening with the AWK? That's what I want to see if you understand a bit.
No, I don't.
All right. Yeah. Okay. You're extracting the parameter that's on the 4th position, but anyway, no worries. The reason why I have asked this question is you are given code that you are asked to modify and use, right, for the sake of making progress, right? But it is important for you to not only understand how to produce effect, but to understand the fundamentals of what that code is doing, right? That's why it's important for you to make sure you thoroughly understand that line of code before you use it for any other purposes, which it may create the effects that you want, but if you don't understand it, there is not very much learning that you get out of it, right? But you can go on.
Yeah.
Let's go.
Okay. Yeah. Um, so yeah, after you have all the functions, you then set the as like in an initial state, you set the linear velocity to 0 and angular velocity to 0, and then you define or I set a then I set a variable of distance threshold equal to 0.3. So that's the 0.3 meter threshold that I have going on. And then I have a while loop that is basically running till I stop it. And in that loop, I define 5 variables: front scanner, left scanner, front left, front right, and right scanner. So just getting in, and then I set those equal to the values from the getter functions. Yeah. And then I define 3 Boolean values essentially with the front left clear, and front right clear. And inside that, it's basically comparing the front left scanner to the distance threshold, and if the whatever scanner you have to the distance threshold, and if the scanner is greater than the distance threshold, it'll return either like a 1 or a 0, saying like true or false. It is clear. And then I print out in this line the values that are shown from either the front scanner, the front right scanner, or the front left scanner, just so that one helps to see, especially in simulation. Sometimes the simulation can go a little awry, or I can also see what's throwing an error for the robot, if that makes sense. And then so we finally get to all the if blocks, which are basically all situations that the robot could be in, where it's, so for the first one, it's just like everything is blocked. There is no place in front of the robot that is clear. So then I set a variable that compares the front left to the front right, and from what I remember, just this means that it will be a Boolean value, so either a 1 or a 0. And so if the front left scanner is greater than the front right scanner, it'll return a 1. And I have that here.
If you so if you tried removing BC in general, right? So if you tried removing it and seeing what that function does if it's not there, do you really need it to be there when you're doing that comparison?
Sorry, could you say that again?
Okay, so you were explaining to me that you put BC after your comparison statement, right? And I was asking if you tried to have it not there, and did it not work when it was not there?
I did not try to remove it. I took so I looked at there was a function that y'all had made beforehand that had that in it for returning Boolean values.
Mm-hmm.
So I
So
I
what
I, I copied that. Or
what functionality does it provide, right? What does it provide by virtue of it being there in the statement?
um I think it defines what type of the I don't know if variable is the right word, but what type of variable it is. Because later on in the script, you'll have BC -1, um, which returns a float value instead of just a Boolean value. Uh, I don't, from my understanding, just the BC by itself returns a Boolean value.
Well, yes and no, right? So
Okay.
again, you needed to have it there because you want the basic calculator to be available. So it's like if you've used Python before, there are libraries that you import in a script, right, to use a particular function. So by specifying BC, you are trying to say to your base script, I need to have the basic calculator available for me to do this computation. So you kind of got 25% of it correct, but the rest of it, I think you struggled a bit there. Okay, let's go on.
Okay. Um, so yeah, okay. So after I have define the comparison result variable, and if that comparison result is equal to 1 or essentially true, then you set the uh, angular velocity to 0.5 to turn left, and then if the comparison result is not true, then you set it to -0.5. So basically, in the opposite angular velocity to then turn right. And then I'll go to one of my more complicated elif statements.
I think
Yeah, I think this one will.
yeah, for now I think that's the only time we've got as far as your code is concerned. So what I want to
Okay.
ask you is some general Linux questions, right? So if you can exit that terminal, I would like you to, as you do that, explain to me what do you understand by environmental variables, like within the Linux shell, and if you are going to make changes to any one of them, how would you do it?
So, okay. So an environment, like just what I understand about environment variables,
Mm-hmm.
and like how, and you said how I would change it.
Mm-hmm. How you change a
Okay.
particular environmental variable, or how you could say, if we're gonna simplify it, how do you list environmental variables that are related to a particular shell or process?
Okay. So an environmental variable can essentially be store whatever you want it to store. It can store, as you saw with my script, a Boolean value, a floating value, or it can store a um, like a string list of whatever characters you want, or it can store other things. Um, and if you want to change it, so you can define. Oh, I guess it was. So you can define the variable beforehand, and then later on, you can set that variable again equal to another thing, and that will, like, say you have the variable set to a true or false statement, but then later on in the code, if you want it set to something else, you can just do the same variable and then set equal to, say, a floating value, like
Mm.
1.23.
Okay, so
Um,
you're explaining how you do it in a base script, I'm assuming. All right. My question was in relation to doing it in the terminal, right? That's what I wanted to understand. How would you do it? And why do you, let's say, need it? Without making it a lot more complicated, maybe you'd need a deep understanding to answer that satisfactorily, but I want to see, do you understand what environmental variables are and how do you make changes to them, or how do you get to list some of them if you want to list, let's say, maybe the ROS domain, for example? Hi, Pete, can you hear me?
I think I know how to do that.
All right, no
Yeah,
worries.
yeah.
So
I don't.
yeah,
Yeah.
no worries. It's part of the Linux course, by the way, so you can check it, look it up there. Okay, let's go to a much simpler process, right? The other thing that I wanted to ask you is, if you are going to make modifications to the permissions of a particular script, right? So if you would maybe open your Linux shell and go to your obstacle avoidance, for example, right? You would notice that it's green. That means it's allowed to execute, right? If you're going to remove the permission to execute, how would you do it?
You do chmod, whatever that is.
Can you be
And
doing
then
it?
sure. I guess that you could. So this will give you the permissions that we'll either. Can I look at my notes for this?
If they are closed, let's see.
If they're, do you want me to put it up on the screen?
Yeah, no worries. The longer we take, the more complex it gets. But anyway, for the time that we've got, I think let's end it here. We can talk about it a bit more once we have wrapped up here. Okay.
Okay.
All right. So just give me 1 sec. Alright everyone, this was Pete's presentation, and I'd like to encourage all those of you who would like to try this course to do so, and then you can also come and showcase your work. And until next time, keep pushing your ROS learning. Bye bye.